Hello and welcome to the second portion of the piecewise functions graphing video. We are going to go a little bit faster, and this is going over the slightly more complicated types of functions that you'd be asked to graph. So, the top equation in this function is a rational function. So we're going to use radii to graph it. Alright, so hopefully you remember that. Now, it's going to be to the left of -4 because x is less than or equal to 4 on that domain. And I already drew a vertical line at 4 so that we had our function split up. So first, let's find the r. So r is none, right, because 1 does not equal 0. A is at x equals 4. Okay, well, we already have that drawn. T is none. E is in behavior, so it's bigger on the bottom, so y equals 0. So we're going to have a horizontal asymptote at 0. And then y is -1/4. So at -1/4, and it's going to cross the y-axis. So right there. Alright, and we'll follow the asymptotes. So it'll look something like this, and get really, really, really close to 4, but never actually touch it. Well, the other side is actually really simple, right, because it's just -4. So it's always going to be -4. Now, that's not or equal to, so when we get to -4, 4, we're going to have an open circle because it's not or equal to, and there's our function. Is this continuous? No. No, because we picked up our pen, and it doesn't reach every x value anyway, which is what we're going to talk about when we're talking about the domain. So the domain here is -infinity, right, because it goes to the left forever, but then it doesn't touch 4. Because that's our vertical asymptote. And it doesn't touch 4 from either side, right? It approaches it and it gets really, 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 really close, but doesn't actually touch. So it'd be -infinity to 4, union 4 to infinity, right? Just like when we were doing our rational functions. Then our range. Our range is actually going from -infinity because it goes down forever, but the highest y value that it reaches is 0. And even then it doesn't reach that because that's a horizontal asymptote. So that's going to be an open parenthesis. It's going to be a parentheses instead of a bracket. Let's do the next one. For this one, we have 2 to the x, which normally looks something like, draw it, that, right? It's exponential growth. And so, because the 2 is bigger than 1, right, it's going to go up instead of down. But we are talking about only from -3 to the left. So this is going to hit that -3 line and be an open circle, right? Because it's not even or equal, right? It's not equal to -3. It's less than -3. And so there you go. Right, that wasn't too bad. Now the bottom one, which is going to be to the right of -3 because it's greater than or equal to -3, is another rational function. So let's go ahead and do our radii. R, none, A, it's actually x equals 0, so I'll have a horizontal asymptote at 0, again, T is none, E and behavior, well it's bigger on bottom, so it's y equals 0, I'm sorry, that was, oh well, you know what I meant, you've done this before. X equals 0 was the vertical line, I apologize, and y equals 0 is the horizontal line. And then for y, it'd actually be 3 over 0, so it's undefined. Okay? So it's undefined, which means, I spelled that wrong. Oh well. It's undefined, which means that in order to find any points, you're actually going to have to probably plot some yourself, right? And plug numbers in. So if I have the number, let's pick something to the right, right? So let's pick 1, right, where x is 1. If I plug in 1, 3 over 1 is 3. So I have the point 1, 3. Well, that's easy enough, right? Because that means that my graph is going to do something like this as I follow my asymptotes. And the only other point that would be really, really, really significant would be something to the left and of the vertical asymptote, which is at x equals 0. Which means that this time I'm actually going to plug in -3. And the reason I'm going to plug in -3 is because it's defined there. right? It's x is greater than or equal to negative 3. So I need to figure out what's happening at negative 3 so that I can plot that closed point. Well, if I have 3 over negative 3, right, because x is negative 3, I end up with negative 1. So I have the point negative 3, negative 1, and that is a closed point. Okay, and that is on that line, because remember, we're allowed to touch those lines. We're just not allowed to touch the asymptotes. And it's going to follow my asymptotes down, like something like that. And there's our graph. Is this continuous? No, we definitely picked up our pen. The domain here. The domain is actually only restricted in this case by the vertical asymptote. And the reason is because even though it's not defined for 2 to the x at negative 3, it is defined for 3 over x at negative 3. So that's going to be negative infinity to our vertical asymptote, which was 0, union 0 to infinity. And the range is going to be from bottom to top. Now, if we go from the bottom, okay, so this is important. If we go from the bottom, we head that way. Kind of stops right here. Right? So we're going to go from negative infinity to 1. I'm sorry. I did not write that. Negative infinity to negative 1. Right? Because that's the y value there. And that point is closed, so it's included. Now what you might notice is that there's like a break. There's a break there. It doesn't touch anything between negative 1 and 0, right? All of this space right here is empty. There's nothing there, no matter what you do, because your rational function that goes this way is going to get closer and closer and closer to 0 and never touch it. Your exponential function, which is here, is going to go that way and get closer and closer and closer and closer to 0 and never touch it. So I'm going to pick it up at 0. And it does go up forever, right? Because you can see that arrow going up. Another one, because I know how much you are loving these right now. All right, number 7. Look at number 7. Oh my goodness. Those equations just look crazy. Okay, and we've dealt with these before. We've dealt with all of these before. We've talked about absolute value functions, square root functions, and then absolute value functions. But given all of this information, I wouldn't know off the top of my head how this might look. Right? Not the way that I do when I graph a rational function or an exponential function or just a constant linear function. So because of that, my suggestion is going to be that you just pick points and plot them. Okay, we have some kind of idea of what these look like, but let's pick points, plot them, make a little table, and go from there. So I'm going to pick x values, and I'll get f of x values. Right, and I'm going to start with numbers to the left of my first border, right? So where x is less than or equal to negative 4, which means I'm plugging it into absolute value of x over 2. Well, I really want to know what's happening at negative 4, because it's defined there on this part of the function. So I'm going to plug in negative 4. All right, let's see what's happening. Well, if x is negative 4, the absolute value of negative 4 is 4 over 2 is 2. And so I'm going to plot the point negative 4, 2. And that is closed because it's included. All right, let's do another one. Let's pick maybe negative 6. See what happens. Right, because I need to know what's happening to the left of negative 4. So I do need to test points to the left of negative 4, and negative 6 happens to be the left of negative 4. So why not? So negative 6, the absolute value of negative 6 is 6, over 2 is 3. So I end up with a point negative 6, 3. Okay, and if you tried negative 8, you would get 4. Alright, so you've got this linear function there-ish. Right, it's an absolute value. There should be a v somewhere. Okay, so that was for that first piece. Let's try another piece. Let's try the piece between negative 4 and 2. Now, even though it's not defined at negative 4, I should probably figure out what's happening at negative 4, because if it's open, I need to plot that open circle as well. So let's try negative 4 again. Right, but now we're dealing with the square root of negative x. So it's the square root of negative 4, so the square root of 4, which is 2. Oh, hey, look, we already had that. It would have been open, but it's filled in, so it's all good. Now I want to find perfect squares, right? So I don't know what the square root of 3 is, right? So I'm not going to use negative 3. I don't know what the square root of negative 2 is. I do know what the square root of 1 is, so I'm going to try negative 1. Right, so it'll be the square root of 1, which is 1. So we'll be at the point negative 1, 1. Okay. And I know what 0 is. 0. 0. So we'll have 0. Let's try 1. 1. Well, then I have the square root of negative 1, which is undefined. So I cannot plot it. And it actually stops. Right, so we can't define anything to the right of 0 because this is a square root function. So that's the only part of the function we get to draw. Okay, absolute value of x minus 2. So let's pick 2 because that's, again, on the border. So 2, and if I plug in 2, 2 minus 2 is 0. So I'm going to have a point at 0 here, 2, 0. And then you just keep going from there. So let's try 3, 4, and 5 just for fun. Well, 3 minus 2 is 1, 4 minus 2 is 2, and 5 minus 2 is 3. So we'll have 3, 1, 4, 2, and 5, 3. Right, and it's clearly going to keep going forever. So there we go. That's our function. Now, is it continuous? No, we had to pick up our pen between the square root of negative x and the absolute value. It's a no. The domain is from negative infinity, and then there's a break there, right? So from negative infinity to 0. Now that wasn't a closed point, so it's a closed bracket. Union, oh, that's another bracket, because that was defined, 2 to infinity. And then the range is actually going to go from 0 to infinity. The reason it goes from 0 to infinity is because the lowest y value here, that's 0. And then it goes up in both directions forever. Okay, last one. Whew. Okay, again, just plot some points. We're going to plot some points, and we're going to see what's happening. And when you do, we're dealing with this here. And now, for the absolute value of x minus 3, let's pick x and y, or f of x, whatever you want to think about it as. It splits at 1. Okay, so whatever's happening at 1 to the left of 1 is going to be an open circle. So if I have 1, I get 1 minus 3 is negative 2, but it's the absolute value of that. So 2, yes. All right, so I have the point 1, 2, so that's open, right, at least on the left side. And let's go smaller, right, so 0, 0, 3, negative 1, that'd be 4, and so on, right? So and that'll go up like that, for as long as you can figure it out. Okay. Now I'm going to plug in 1 into the middle portion, okay, because that's where it actually equals 1. That's going to give me a very important point. Now if I have 1 minus 1 is 0. 0 to the 4th power is 0. So that's just going to be the point 1, 0. Which means I've got this random point down here on my graph. And that's okay. It is okay. Alright, so that's that portion. Now let's graph the part to the right, so the square root of 4x. So let's plug in 1. I need to figure out what's happening at 1. Okay, see if I can actually, and I can't fill in this circle up here, but maybe it'll touch the point at the bottom? Who knows? So the square root of 4 is 2. So another 1, 2, okay. Alright, so I got that right there. Then let's pick, perfect numbers. 4 times 8, I don't know the square root of 8. No, I don't know the square root of 12. I do know the square root of 16. So let's pick 4. Right, the square root of 16 is 4, so it's 4, 4. So we've got the point 4, 4. Which means this is going like that. And I know it's curved because we know what a square root function looks like, right? It's that little swoosh to the right. So is this continuous? No. No, and only because there's that hole there, right? That's me drawing and picking up a point and drawing a little circle, okay? So it's not continuous because that point isn't filled in. The domain is actually all real numbers because every x value is accounted for. And the range, this is interesting. So the lowest y value is technically 0, but it doesn't go above 0 or below 0 at all. So I'm going to put a bracket and a 0, and then union the other piece, which is going to be from 0, which is going to be from 2 to infinity. And there you go, some extra practice for you. Have a great day.